Hey, listeners, great news that you don't want to miss. On April 8th, Pam is doing a webinar with our friends at Number Club.
We're talking about games that make kids want to think, not just memorize.
No drill, no mindless repetition.
Just real mathematical reasoning disguised as seriously fun games.
If you've ever thought, my students can do the steps, but they don't really understand,
Or if you thought, my students can't do the steps and they don't understand, y'all, this is for you.
register here, www.mathisfigureoutable.com/numberclub-games-webinar. That's mathisfigureoutable.com/numberclub-games-webinar.
Come and see what true fluency actually looks like. Now, on to the show. Hey, fellow mathers. Welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
We know that algorithms are super cool historic achievements, but they are not good teaching tools because mimicking step-by-step procedures can actually trap students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
Y'all, thanks for joining us to make math more figure-outable. All right. Hey.
I never realized that the breathing thing, but now I've heard you three episodes in a row. I did not know that was you've held it well. I think you've mentioned it before, but I didn't know it was really that much
funny.
of a thing.
Maybe I'm out of shape these days.
I buy that talking for a long time without breathing is a thing. Okay, today part 3, factor puzzles part 3. We tackled whole numbers. It might have had a decimal in there somewhere.
Yep.
We tackled integers. What is up for today?
Today, we are going to go farther into the future, into higher math. We are going to do some stuff with algebraic expressions in factor puzzles.
I actually, you're right. I saw that because can I say what your note to self is?
Oh, okay. Yeah, what?
Listen, listeners,
there
are some episodes where we're like, hey, we're going to do some math. And Pam's like, I'll do a string. And that's kind of it. That's like the whole note. And there are other times where we want to talk and we leave a few notes. For sure, we have the podcast intro always in front of us because
we don't have it memorized.
If you've ever seen us present together recently, you will know we cannot get it right. It's a mess. We laugh every time because we should know this after 300 episodes. But we don't. And so I just looked on the document I pulled open. It says, Pam, look in your iPad notes for problem string expressions. So that's the entire note for today. And so I have absolutely no idea what we're doing.
So Kim's taking a deep breath.
We'll see how I do.
Bam. It's going to be great. All right, y'all, if you haven't listened to the last 2 episodes, you might want to grab one of them before you listen to today, but you don't have to. But we're working on factor puzzles, which is a great routine that we can start as young as 3rd grade and then take it all the way into high school. We really wish that younger grade teachers would, high school teachers really wish that this routine would happen with younger grade students a lot to get the relationships happening because it will help later. So the way that we've talked about that in the last 2 episodes is, I'm not doing this very well.
We need more notes.
Yeah. Okay. I'm going to talk about what a factor puzzle looks like briefly for those of you who haven't looked at the other 2, and then we're going to dive into expressions. So I might give you a factor puzzle that looks something like the top number is 36. And then there's 2 numbers that are underneath that, kind of straddling it. So 36 is sort of in the middle, and then 2 numbers underneath it. And then there's a 3rd number on the bottom. And that 4th number on the 4th number, thank you, I can count, is 12. So the top number is 36 and the bottom number is 12. Kim, tell us how you're thinking about filling in the middle 2 numbers, and then we'll kind of come up with some, what are you doing?
Okay. So I know in factor puzzles, the rules of the game are that the 2 middle numbers multiply to give you the top number. So the top number is the product, and the 2 numbers add together to get the bottom number. That's the sum. So when I saw 36 and 12, I knew that it had to be 6 and 6 because 6 times 6 is 36 and 6 plus 6 is 12.
Okay, cool. And I'm going to give you one more just so everybody can practice.
Okay.
So still the number on the top is 36.
Yeah.
And this time the number on the bottom is 20.
Okay. So I'm thinking, I'm kind of rolling through 6 times 6, 9 times 4, 2 times 18. So 2 and 18 are the two middle numbers.
Because 18 times 2 is 36 and 18 plus 2 is 20. And like we've mentioned in other episodes, notice how Kim thought about the factor pairs and then checked each of them to see if they summed to that last number. She did not think about what are all the numbers that sum to 20 and then check to see if they multiply to 36. So that's something that you would want to come out with students. Think about the factor pairs, see if they sum. Don't go the other direction. It's much too inefficient to go that way. Okay. If those are the relationships, we're going to multiply the two middle numbers to get the top number. We're going to add those two middle numbers to get the bottom number. When I give you a top and bottom, you're kind of asking yourself, what two numbers multiply to this number, but also sum to this other number? So Kim, what if I gave you a top number today? Oh no, shoot. Let me do one more thing. A reason to do what we just did with Kim is to get students thinking about those relationships, because those are the relationships that we need kids thinking about when they factor a quadratic trinomial. So if I have a quadratic trinomial in the form of ax squared plus bx plus c, and I want to factor it into x plus or minus a product, plus or minus a number times the quantity of x plus or minus a number, then those two numbers are going to multiply to be C, and they're going to add together to be B. So that those relationships are alive and well when we're factoring those quadratic trinomials. I hope I just said all that right. All the words. Therefore, it is helpful. But algebra teachers, once you do the kinds of problems, the kinds of factor puzzles that we've done in the last two episodes, you can also break free from those quadratic trinomial relationships. Like I like them and I want them and I want to develop them and get students good at that, and then let that help students factor quadratic trinomials. But I also think we can then break free and do other factor puzzles to help kids get better at just multiplying variables and simplifying expressions. So we're going to have these four numbers, one on the top, two in the middle, one on the bottom, numbers of expressions this time. So in the top box, Kim, will you please write x squared? And in the bottom box, will you please write 2x? And then please tell us how you're thinking.
I know that x squared is x times x.
Okay.
And that's convenient because I know that x plus x is 2x's.
Nice. So you just filled in the middle two boxes with x and x. Cool. All right, so everybody just think about that for a second. One of the things that kids mess up early when we're asking them to think about variables is the difference between x squared and 2x, and x plus x and x times x. In a huge way, we just kind of like, we're not expecting students to just know this. We would do this with kids and kind of talk about the differences. Let's continue to ferret that out. So what if, Kim, in the top box, we had 2x, and in the bottom box, we had 2 plus x? Now what are you thinking?
Then I'm going to make 2x. What did you say was on the bottom? 2 plus x? Then I'm going to put 2 in one of the boxes and x in the other box.
Because
2 plus x is 2 plus x, and 2 times x is 2x.
Cool. And you just told us the bottom thing first and then the top. Yep. So the product of 2 and x is 2 and x. The product of 2, how do you say that? 2 and x? I feel bad saying and there. It feels very additive.
2 times x
is 2x, and 2 plus x is 2 plus x. Okay, cool. Here's another one. Well, actually, if you look back at the two that we just did, you'll notice that we've got 2's and x's floating all around. One of them's a exponent. It's a nice way of then having kids sort of look back at these two problems and go, okay, wait a minute, what's happening? Why is this one 2x and that one's x squared? And why is this one 2 plus x and that one's 2x? Lots of nice things that we can sort of ferret out about what's happening. And if we're not sure, that you could put a number in there and have kids actually, like what if X was, I wouldn't do 2 because 2 plus 2 is 4.
Yeah, lots of 2.
But you might do 3 or 5 or something, do a prime number. And then, talk about, does that sort of work? Okay. And then you can go back to variables. Cool. Here's another one. What if the thing in the top box is 3x squared and the thing in the bottom box is 4x? Love hearing your thinking out loud.
So I'm going to make 3x and 1x because I know that x squared has x times x.
Okay.
And so I'm just going to make one of them 3x, and which means so I guess I said 1x, but it could just be x.
Sure, because we've gotten lazy, and by convention we don't put the coefficient 1 in front of x. But you could. I actually like the fact that you said 1x. Okay, so
I will write it back just for you.
So 3x times x is 3x squared, and 3x plus x is 4x. Again, a nice way of sort of juxtaposing what those mean. All right, here's another one. I'm going to also put 3x squared in the top. Can I just ask what you're thinking right now?
I said to myself, that is 3 times x squared.
Okay.
And so I know that the 2 middle ones are going to be, I guess it doesn't have to be. I was going to say, I know that should be x times x. But I guess theoretically, one of them could be x squared. Well, and the other one could be 3.
Yeah, I like the thinking that you're sort of like playing around with what are all the ways to factor 3x squared.
Yeah.
It's nice. Okay, the bottom is 3x squared plus 1.
3x squared plus 1. Oh, so then none of the 2 options that I just said. One is 3x squared, and the other box is 1. Tricky trickster.
Because 3x squared times 1 is 3x squared, and 3x squared plus 1 is 3x squared plus 1. Okay, cool. The top box, you ready? You're never going to guess. Is 3x squared.
Shocker.
The bottom box is x squared plus 3.
Squared. Oh, say that again. The bottom box? I automatically went to the middle box. Okay, 3x.
Oh, yeah. So 3x squared in the top and x squared plus 3 in the bottom.
Okay, so one of the middle boxes is x squared, and the other one is 3.
And do those indeed multiply to 3x squared? Sure enough.
Yep.
Cool.
Yep.
Okay. So there's one series of problems that you could use algebra teachers. It's not about factoring quadratic trinomials at all. It's really just kind of helping kids get a sense for like, when are you multiplying variables? When are you adding variables? What does that mean?
Yeah.
And simplifying expressions. It's a chance to sort of juxtapose things and kind of get more solid about that. Did you want to say?
I was just going to say that since that is such a huge confusion for so many kids, I think this is a really nice way to put it out in front of them and to have to tinker and have discussion and acknowledge that that's a thing.
Yeah, nice. Consider that when we start working with variables with kids, if we have kids that are stuck in counting strategies or additive thinking, and they really have this sense of multiplicative reasoning, then it is harder for them to think about something like 3x. Because if I write 3x, they are seeing a 3 and they're seeing an x. And especially if they're additive thinkers, they're like, there's a 3 and there's an x, and they're going to see that as a 3 plus x, a 3 and an x together. It's much less for them 3 times x or x plus x plus x. There are ways that we can help with that. And one of my favorite strings that I've just come up with recently, we call factor to add or factor to subtract. Pretty sure we have podcast episodes on that. We'll put that link in the show notes, where we end up with students doing problems like 9 times 7 minus 4 times 7. And the kids we pull out of them to think about 9 sevens minus 4 sevens. And they're like, I can just solve that problem. I know 9 things minus 4 things. That's just 5 things. So I can think about 9 sevens or 63 minus 4 sevens, like 63 minus 28. I can think about that as, 9 minus 4 of them, that's just going to be 5 of them. And I know that 5 times 7 is 35. And so I can actually solve that subtraction problem by thinking about 9 of a thing minus 4 of a thing And then as algebra teachers, we could write, oh, it's almost like you're thinking about 9x minus 4x or 9, like we just put variable in there instead of the thing. It's a way of getting kids to reify what a term is.
Mm-hmm.
A term is connected with multiplication. We then add and subtract terms from each other. So terms are connected with addition and subtraction. They're created with the things in a term are connected with multiplication and division, and they're connected by addition and subtraction. I can tell you that, but we need kids to have experiences so they reify this idea of what it means to have something like 3x, that 3x is not 3 plus x. So what's the difference between 3 plus x, 3x, x plus x plus x, even then x times x, and x cubed? All the differences between those we can help differentiate with experiences like this. So Kim, will you do one more with me?
Sure.
What if the top box was x times the quantity x plus 1?
Mm-hmm.
And so like if you looked at it written, it was x parentheses x plus 1 close parentheses.
Mm-hmm.
And that was for podcast listeners, not for Kim. And then the bottom box is 2x plus 1.
Mm-hmm.
What do you got?
I know that x times x plus 1 can be x on the left side and x plus 1 on the right, or the other way around.
Yeah.
So
because multiplication is commutative.
Yeah. So my factors are x and x plus 1.
And do those sum to 2x plus 1?
Yeah.
Because you got x plus 1. Yep. That's 2x plus 1. Nice. Cool.
Yeah.
So high school teachers, just you could have a little fun with this if you wanted to. I don't know that I actually even recommend what I'm about to say, but you could do this. Kim, last problem. What if in the
you said last problem on the last problem?
Okay, that was I lied.
You might not have.
Did I really? I don't remember.
Maybe not. That's what I heard in my head.
Sorry, I apologize.
That's okay. It's fine. No problem.
The actual last problem. What if in the top box it was x squared plus 7x? Well, shoot. Should I go this direction? Yeah, I will, since I started. But then remind me to go back. So x squared plus 7x plus 12. X squared plus 7x plus 12.
7x plus 12. Tiny handwriting. Okay.
Oh, sorry. Yeah, I should have said big box. Big box on the top. Big box on the bottom. 2x plus 7.
2x plus 7.
What are the factors of x squared plus 7x plus 12 that sum to 2x plus 7?
Okay. So I am thinking about, I want x to be in each of the boxes, like x on the left, x on the right. And I want two things that add to 7 but multiply to 12.
Okay.
So I want it to be x plus 4 and x plus 3.
And do those sum to 2x plus 7?
Yes.
Sure enough. Nice. Mm-hmm. Now, high school teachers, you might look at that and go, we don't ever have students sum the factors once they factor that quadratic trinomial x squared plus 7x plus 12 into x plus 3 times x plus 4. Once we've done that, we don't ever have them add them. Okay, fine, you don't. But I wonder if you could actually give kids factor puzzles like the ones that we've done all day today and in the past 2 episodes, and then give them one where you give them actually the 2 middle numbers. Give them x plus the middle numbers, 2 expressions. Give them x plus 3 and x plus 4, and let them multiply them and let them add them. And do a bunch of factor puzzles where they're actually doing the multiplication first before you then ever do the other direction. And if they're used to factor puzzles, they know they're going to be factoring because you've given them the top and bottom numbers before, or top and bottom expressions before. And so it's just this fluid flowing between, am I multiplying? Are we adding? And what does it mean with variables and expressions? I think it could be a really nice, fairly quick way of, again, do this early and then just pepper independent work with it often. Warm-ups and exit tickets and on homework and any time you can, just have 1 or 2 of these factor puzzles show up, compare, have students talk about their reasoning. You got a great routine going on.
Factor puzzles good for grades 3 and up in lots of different ways. If you have not checked out the blog on factor puzzles, you can find that at mathisfigureoutable.com/blog.
Y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Thanks for spreading the word that math is figure-outable.
Thanks for joining us, and remember about the Number Club webinar on April 8th.
Number Club games hit different because kids see the relationships, build the relationships, develop the relationships.
They're planning, experimenting, and thinking strategically.
That's the kind of fluency that transfers.
If you haven't registered yet, there's still time. Register here, www.mathisfigureoutable.com/numberclub-games-webinar.
Y'all come and learn more about the games that make math figure-outable and keep making math figure-outable.